Hi everyone, so this is the part 2 for that ZYNQ SoC where we are combining, I'll just open the paint, where we are combining this programming logic and processing system, programmable logic. Why I'm calling it programming again and again, I don't know. So this is what we have done in the previous video. We have designed the programmable logic XOR gate, we have tested it in the FPGA also, and now we have to link this processing system part. So we will launch the VTIS IDE. So I'm using, where is the tools, I'm using the VTIS IDE 2025 version. Vivad is also 2025 itself. This is a unified IDE. There is no previous video for that. That's why I faced the challenges. That's why I'm making this video to you. So first of all, we have to create a new platform as discussed in the previous video, where we have to create the platform in the same project folder. The project name is half adder SoC. This is our project. You can rename it. I'll keep it at same platform. You have to select that hardware design. What is that file? That file is .xsa file in the same folder. Vivado. This is .xsa file. Based on that, it will select the operating system and processor. We will wait for that, and then our platform will be created. Finish. Click on update. You have to wait for this thing to complete it. Here bottom right, top up will come, that platform creation successfully, then only move to next step. It will not take more time. As you can see, platform creation successfully. So now we will start from the example of hello world itself. We'll modify the program, add hello world. Now I'll change the name, component name to, what is that, half adder. Half adder, same project folder, link to that, link that component to the platform, everything same. Finish. Okay, now just build. Okay, first we'll build this platform to get the library update itself, because as I told you in the first video of the ZYNQ, we have to do this once. Build the platform. Once this platform is built, it will automatically add the libraries. In the half adder, go to the, where is that half adder sources. This is the hello world.c. You can rename it over here. That is our half adder.c. That is fine. Got it. Now we'll add some libraries. So why we need the libraries? We need the libraries because we are using the now that GPIO ports, right? So what is that library? Hash include xgpio. Everything is small, xgpio.h. Okay, now it is there. Fine. One more library we need, h parameters, x parameters, not h. Hash include x parameters. Why it is not come? It has to come in the list. X parameters dot h. Okay, so it is there. You can select this as library. Okay, only these two extra libraries we need. We can keep this printf or we can remove it, but it is fine to keep this printf as a debugging statement, because anyway it will automatically work. So we'll write it as started half adder. Great. Now we will write some codes. So how you will start? First you have to make a pointer. So how many input outputs we need? So let's go to our design again. So one pointer will be for this input 1, one pointer will be for this input 2, one pointer will be for output. So let's make it. How you will make that pointer? X GPIO, not int, oh, sorry, X GPIO itself you will write, then you will write input 1. You can name anything. I'll just name it like this only. Done. Now we have to define the variable also. How many variables here you need? Pointers is different thing, variable is different thing. Hopes your C concept is clear. 1, 2 and A, B and C. You can call it anything. Input A, comma B, comma C. Fine. Now we have to initialize our XGPIO ports. That AXI things that you have used, right? AXI blocks. Now you have to start that. For example, here you are initializing your platforms, right? Like this, you have to initialize the that GPIO ports. How? X GPIO XGPIO underscore initialize. We have this command initialize. So it will be having the base address and then it will be having the pointers. So first we will initialize. Sorry if some background noise is coming. First we will initialize input 1. What is the base address? Base address will be xpar underscore 0. Okay, this one. Base address 0. If you are using the old Vitis version, that is before 2024, then instead of base address you have to write device underscore id, like this, device underscore id. But in latest Vitis version, this device id is integrated into base address itself. So now over there you can see we are using GPIO 0 as input 1. So that's what I told you, right? In the block diagram also, if we just go to block diagram, close this hardware. Where is my block diagram? Open block diagram. See, this GPIO 0, EXI GPIO 0 is working as channel 1 and channel 2. Both channels are input channels, right? So that's why we have defined this. Then use semicolon. I'll just copy paste this line because input 2 is also using same EXI port. Next, output. Just use the same. And then we have one output. Output is using different channel, that is, again I'll write AXIPAR underscore AXI, wait, AXI, and this is AXI1, right? AXI1, why that is not coming? AXI1 base address. So like this, here I have initialized the AXI0 block, here I have initialized the AXI1 block. I guess there is no need to initialize this thing twice because this complete block itself is one time only, right? Either you call it two times or one time. I have not tested it. Later you can test this thing and I also will test and let you know in the comments. After this initialization, we have done for input and output both the things. Now we will set the direction. So if you are familiar with any microcontroller or some Atmega, so we have to decide what data direction is over there, right? So that port is working as input port or output port. Either it is connected to input pull up or output pull up, like this. We have to define over here. How you will define? X GPIO underscore set data direction. Then you have to write first pointer. What is it? Pointer input 1. This is channel. Which channel we are? Two channels we are using, right? First channel, and how many? And what is the mask? Mask means 1. What will be 1? I will just write here mask equal to 1 means input, and mask equal to 0 means output. Sorry if any spelling is wrong. So this is the pointer 1, that is input 1. It is connected to channel, because here if you go to the diagram we are using two channels, right? This channel 1, channel 2. So this channel 1 is using as input mask 1. This value is 1. 1 means input. If you are using multiple width over there, then you can use this like this, 0x ff. Whatever marks is input output, you can keep like this 1 0 1 0. That is fine. This will also work fine. But we are using only one channel, 1 bit width. As you know, here this bit width is 1 only, right? That's why we are using only 1 bit. Same thing will set for input 0, but input 2, but input 2 channel is second. Okay, so now here only it will define this input 2 is connected to AXI GPIO to GPIO 0. So yes, you need this line. You cannot skip that line. So now this is also defined as input, right? Again, I'll just paste this line, that is output. Now here I will be using channel 1 only. In the output port, we are in this output. This is AXI GPIO 1. Only one channel is used, that is as output, one word. If it is using as output, you have to give it 0. Channel 1 output, fine. Everything is fine. So now we have set that, we have initialized that AXI ports, AXI blocks. We have set the direction. Now we have to start writing our main code. While we will write one infinite loop. So this is C programming. So now you have to read the values, right? You have to read this input A and input 2 values, and you have to give to this A and B variable. How you will read the value? Like this: A is equal to, how you will read, X GPIO underscore discrete read. What do you have, from where you have to read? Input 0 pointer. So not input 0, input 1. And what is the channel? This channel is first channel, right? Just write semicolon. Again, I will just copy paste this line to do it fast. This is B. B will be reading from the input 2, and the channel is also 2. So now I have that same data I have read in the A and B. So now I can use anything. For example, what I have to do? What is my design code? First, this is A. Understood? This is A. This is B. If you just go to this design wrapper, in this block diagram, you can see this Y. Y, that is sum, right? Sum is connected to channel 1. Here also, that sum is connected to A. Here you can see that some channel 1, this channel 1 is input 1. Input 1 is A. So first I have to do A, this is A bar. First I have to do A bar, then this B, then this A bar, A. A bar B, A bar A. I have to just add this thing. How you will do that? A is equal to A bar, and then what is the output variable? C, na? C is equal to A and B. What is B? B is that is reading from this channel 2. What is channel 2? Channel 2, this is channel 2, right? Channel 2 is coming from this A. So it is reading A bar A. Understood? The terms are confusing, but that is why this is not a digital design course. This is not a tutorial for digital design. The terms may be confusing, but the thing is how you will integrate that is important thing. Now you have to set this C value. C is output, right? You have to set this C value to this pointer, output pointer. How you will set that? For example, here you have read that value. Now same thing, you have to write that value. X GPIO underscore discrete write. How you will write? What is the pointer? That pointer is output. Which channel? Channel 1. We are not using two channel. What is the mask? Mask means what is the value? Value is C. Comment it out. Then everything is fine. No need to other thing. See here what we are doing. Now you will just see again. We'll go one by one. First we have added the libraries for GPIOs. Then we have assigned as pointers and variables. Then we have initiated that AXI ports as this pointer. This port is assigned to this pointer. This port is also assigned to this pointer. And this output port, output AXI block is assigned to this output pointer. Then we have set the mask, which channel we are using, how many channels we are using, and what is the mask it is using as input or output. These two are input, this is output. Understood? Next we have read that value. We have read that value, like input 1 is going to A, that is some value, and that this input 2 is the A value. So first we are doing this sum, we are doing the inversion of the sum, then we are doing the AND, and that is what my operation is, right? First you have to do the inversion of the sum, then you have to do the this inversion, and then you have to do that AND gate of both, then you will get the C. How you are assigning the C value? Because C here display write C. What is the output? Output is this GPIO1 base address. If you go to the block diagram of GPIO1, this is the GPIO1, only one port is output, that output is carry, so it will be automatically connected like that. So let's see now how to make it run. So first build the project. Hope so there will be no errors. Okay, build is completed. Build for half adder with errors. See the output windows. So what is the error? Problems. Half adder build failed. But where is the error? Actual error. Is there any mistake in this code? Let me just see. This is while. Okay. This is fine. From here it is coming. This is fine. We are defining that value. Then we are using this thing, data direction. Got it. This is one base address. Done. 110. No issue. We have used the semicolon everywhere. Right. Let's again build it. Generated platform successfully, but there is some error. But where is that error? Okay, then I'll pause this video for some time. I'll get to know which error is that without wasting your time. Okay, so I got it that error is in the not in our code. So what is the error? So it is saying, so as you know, we have renamed this half header, right? Previously it is hello world.c. So that's why it is the CMake file. It is not able to find that file hello world.c. So we have to modify this thing. How, from where we'll modify? Go to this half header settings, then this cmake dot user config dot cmake. Here you will see what are the sources. So in the sources just rename it, otherwise you don't rename this name. If you have to rename, then you just make it same, half underscore adder dot c. Okay, done. Now just save it, run it, save. I will just do save, build. Now build is completed, green tick. Now before running this thing, we have to deploy the bitstream file. So program device, this is automatically selected, auto detect program. Make sure that your FPGA is connected. Mine is already connected. So program device finished successfully. Now you have to run this code. Before running this code, as we have already added this start half adder, right? So I will open the terminal again, once again, serial monitor, same board, done. Now I will run this thing, continue. What is this yellow? There is some warning over there. That fine, it is fine, it is working fine. Started with started half adder. Okay, now if I just turn on my camera, just give me a minute. Yes, so now over here you can see my camera, and this is the FPGA, right? Can you see the LEDs? Okay, now it is fine. These are two switches. This is this is some LED, this is carry LED. So now if I just turn it on, 0 0, that is 0 0 itself, 0 1, the sum is 1, carry is 0, then 1 is 1 0, sum is 1, carry is 0, then both are 1 1. Now you will see, glad, ho ho, my carry is 0, sum is, carry is 1, sum is 0. So this is the half adder, right? So this is working fine. So thank you very much for watching this tutorial. Hope so you like this, and if you do like this, please do comment, and thank you very much. Bye for now. Have a great day.